Right now, as you sit there, you might feel perfectly still. But you, the Earth, the Sun, and every star you see are hurtling through space at more than 2 million kilometers an hour. Almost a century ago, Edwin Hubble realized that nearly every galaxy in the sky is drifting away from us. Space itself is stretching, carrying galaxies along in a smooth, uniform outward flow. But our galaxy refuses to follow that orderly script. The Milky Way is slicing straight through that universal expansion at a staggering, highly specific speed. Astronomers call this extra movement a peculiar velocity, and a peculiar velocity is never random. It is the specific signature of gravity, meaning something massive is reeling us through the dark. To measure the speed of an entire galaxy from the inside, you need a stable backdrop. Astronomers use the cosmic microwave background, the faint, stationary afterglow of the Big Bang that fills all of empty space. This map shows the temperature of the cosmic afterglow. One half appears slightly warmer, the other cooler. As we rush in one direction, the light ahead is squeezed, looking hotter, while light behind stretches and cools. By measuring that tiny imbalance, this cosmic speedometer gives us an exact number. We're moving at 600 kilometers per second. But when astronomers looked in the direction we're being pulled, they hit a physical wall. The enormous mass dragging us through space sits almost directly behind the thickest, dustiest part of our own Milky Way. The light of billions of stars and dense lanes of interstellar dust completely drown out whatever lies behind them. Astronomers call this the Zone of Avoidance. Our home galaxy acts as a cosmic blindfold, hiding the biggest gravitational giant in the exact direction we cannot see. To see through a wall of dust, you have to stop looking with visible light. Astronomers turn to massive radio dishes, like the Parkes telescope in Australia, to catch the longer wavelengths that slip right through the haze. When the curtain finally lifted, they found a giant. At the heart of the blind spot sits the Norma Cluster, an enormous concentration of galaxies sitting nearly perfectly still. In the rules of gravity, the thing that sits still is the floor everything else is rolling toward. This became known as the Great Attractor. This graphic tracks our target speed of 600 kilometers per second. Norma's massive gravitational pull only accounts for half our velocity. Even adding the colossal Shapley Supercluster found farther out, the combined pull still falls completely short of our actual speed. Even after mapping the greatest concentrations of matter on the cosmic horizon, the numbers simply did not balance. The assumption that mass attracts mass could not explain how we were moving. To explain the rest of our velocity, astronomers had to look at how gravity behaves in reverse. We are used to dense clusters pulling us from the front, but our speed is also dictated by empty spaces pushing from behind. In this model, if one equal gravitational anchor disappears, the center object drifts away from the new emptiness. The void simply fails to pull back. Tracing cosmic streams, researchers found exactly this: an enormous, near-empty region behind the Milky Way called the Dipole Repeller. That giant void acts exactly like a repeller. Our 600 kilometers per second is the sum of the dense clusters dragging us forward and the silent emptiness shoving us out. The Milky Way is being steered by two distinct hands on the wheel at the exact same time. One is made of matter, and the other is made of nothingness. By mapping the precise directions of these pushes and pulls, rather than just plotting where galaxies sit, astronomers realized they could trace the invisible boundaries of gravity itself. Think of it like a cosmic watershed. Just as rain falling on a mountain range drains down into distinct separate basins depending on which slope it lands on, galaxies flow toward their local gravitational floors. When they charted the edges of our own basin, they outlined an interconnected web woven from 100,000 galaxies. They called our home supercluster Laniakea, meaning immense heaven. Yet inside this structure, our position is surprisingly humble. The Milky Way sits nowhere near the center, and we are nowhere near the great clusters that dominate it. We are perched all the way out on the ragged edge. We live right on the watershed divide. A single nudge in the deep past could have sent our galaxy falling the other way, draining into an entirely different basin, with a completely different universe of neighbors. So the next time you look up at a seemingly still and quiet night sky, remember that you are entirely a part of this cosmic tide, falling continuously toward a horizon no one has ever seen. We have managed to map the currents of a sea we can never physically step outside of. If standing on the cosmic shoreline changes how you see the universe, take a second to subscribe and like the video. It helps us build more journeys out to the edge of what we know. Leave a comment with your thoughts on what might be hiding out there in the dark, and we will see you on the next exploration.